This lecture is about air pollution and control. Let's see the intended learning outcomes. Uh, from this section, you are going to learn about what are the sources of pollution. Pollution, in this section, we specify the pollution about air pollution. Then you should know the health effects and the global impacts caused by the atmospheric pollution. Then you should learn air quality monitoring and standards. Then at the end, you will learn what are the air pollution control methods and the ventilation method. What is air pollution? So according to this slide, you can see the definition. Air pollution is the introduction of chemicals, particulate matter, or biological material that cause harm or discomfort to humans or other living organisms, or cause damage to the natural environment or built environment into the atmosphere. That means air pollution is the release of unwanted things into the atmosphere. So, what are the unwanted things? So, those unwanted things cause harm or discomfort to the human beings and other living organisms and to the environment. And the students who learn environmental science or environmental technology, you should know that our environmental can be divided into two categories: the natural environment. So we have natural environment and the built environment. In some textbooks or in some literature, you can find the environment can be divided into green environment and the brown environment. Okay, so the brown environment is the built environment. So air pollution is the emission or release of unwanted things into the environment, and those air pollutants can cause discomfort and harm to the living beings and the environment. So the harmful things are the chemicals, maybe in gaseous form or maybe in liquid form, and particulate matter and biological matter. Then let's see the air pollution sources. So we can categorize sources of air pollution into the natural sources and anthropogenic sources. Natural sources and anthropogenic sources. Natural sources are volcanoes and forest fires. Okay. So from natural sources, SOxes, NOxes, methane, dust, nitrogen sulfide like gases are emitted. So even CO, CO2 and suspended particulated matters also can be emitted from the volcanoes and also from the forest fires. So you may have heard about forest fires. So in year 2019, you may heard about bushfires in Australia. Okay? So bushfires in Australia uh, are widespread and it's regularly occurred. It is regularly occurred, and it is caused due to the natural phenomenon. Because of that, it shaped the nature of the Australian continent. Okay, so from the bushfires or forest fires, significant uh, amount of property can be damaged, and human and animal life can be lost. Okay, so uh, smokes generated from the bushfire is made up of very small particle and gases. Smoke particles in the air can irritate uh, human and animals' eyes, nose, and throat. And these particles can uh, penetrate deep into the lungs and aggravate existing lung and heart conditions. So therefore, the forest fire is a threat to the human and living beings. It also damage the properties, but due to the air pollution cause it cause health adverse health effect to the human and the animals. And the other things, the forest fires or bushfires emit carbon dioxide into the atmosphere, causing greenhouse gas effect. Then let's see anthropogenic sources. So anthropogenic means a man-made. So uh, these are the examples for anthropogenic sources. So sulfuric acid manufacturing industry emit the SOxes, SO2 and SO3 during the production process. Then coal power plants emit SOxes, NOxes, carbon monoxide, carbon dioxide during the power generation process. I hope all of you are familiar with the uh, steam steam power uh, plant. Okay, so during the power generation process, to produce the steam, the boiler is used. The fuel for the boiler is the coal. So during the combustion process, these carbon monoxide and carbon dioxide is produced. So during the combustion process, CO2 is produced, and if there is a partial combustion, if there is no full combustion, if there is no excess amount of oxygen, then carbon monoxide can be emitted from the production process. Then SOxes are emitted because in the coal, the fuel that we use for the coal power, the steam power plant, the coal may contain sulfur impurities. So during the combustion process, sulfur is converted into SO2 or SO3, so called SOxes, and NOxes are also emitted. So NOxes are that mean one example is of nitrogen dioxides. So during the combustion process, the fuel NOx and thermal NOx are emitted. So if you want to know about fuel NOx and thermal NOx, you can refer the handout number 2 given uploaded in the Moodle. So in early month of May or in early April, I uploaded all the handouts of the air pollution and control section. Then refineries. So the refineries, so we can say the petroleum refinery where crude oil is refined to produce diesel, petrol, uh, kerosene, LP gas like that, and also the bitumen or tar. So refineries also emit SOxes and also the NOxes, hydrogen sulfide, and some hydrocarbons are emitted during the production process. So uh, they are responsible for the air pollution. Then during the dye manufacturing process, hydrogen sulfide is emitted. Then canneries also emit H2S. What is canneries? What is canneries? A cannery is a factory where fish, uh, vegetables or other foods are canned. Canneries mean a factory where uh, fish, vegetable or other foods are canned. So when we talk about the cannery, a factory where fish, vegetables, and foods are canned, they also need some energy to do that. So they have heavy machines and equipment, instruments. So electricity or energy has to be given. Then there may be separate power plants for energy generation. So it may be a diesel power plant, or it may be a diesel driven boiler, or kerosene driven boiler. Then the suspended particulate matter, CO, CO2, SOxes, NOxes are emitted. And during the production process, some uh, gases can be emitted. Then I would like to mention about the tannery. The tanneries. The tanneries is a place or factory where skins and hides are tanned. Tan mean to make animal skin to the leather. So when you learn the water and wastewater treatment section, you may heard that for the tanneries industry, there's a special regulation for the wastewater discharge. So now here we are talking about canneries. Then from burning fuel, again noxes and SOxes are emitted. So not only noxes and SOxes, but also CO, CO2 and hydrocarbons can be emitted from our domestic sector, from our houses, from our institutes, schools, campuses, and government offices. They have to burn fuel to generate energy for cooking, for lighting, and other purposes. So during the whatever the fuel we use, air pollutants are emitted. Then organic chemical industry emit hydrocarbons. So there are many organic chemical industries. Then paint and coating industry, hydrocarbons are emitted. Then textile industry, they also emit hydrocarbons, and in those factories they need steam, hot water for washing and other purpose, washing of clothes, for other purposes. So they also have to run separate boilers for that. Then they have to use fuel. Then again they emit CO, CO2, NOxes and SOxes. The mining industry, especially, they emit particulate matter. Then cement industry, they especially emit particulate matter. And for the cement industry, they have to make clinker. The clinker from the uh, minerals, like dolomite and other soil. Then those has to be subjected to a very high temperature. For that they have to use a uh, kiln or furnace, so which is run by using coal. Then again carbon monoxide, carbon dioxide is emitted from the cement industry. Then fuel power plants also, the particulate matter can be emitted. We can say if it may be a renewable energy sector, dendro power plant. Again, by when we use a dendro power plants, or when we use fuel wood, then particulate matter, suspended particulate matter can be emitted into the atmosphere, which cause the air pollution. Then okay, type of emissions. Let's see. So we can categorize emission type into mobile sources or stationary sources. So vehicles are the mobile sources of air pollutants. Stacks, stacks and chimneys are uh, stationary sources of air pollutants. Hmm. So I would like to share what are these? Are they what are these things? Are they chimneys? Okay. What are they? Okay, you can find whether these are chimneys, cooling tower, or stacks. So when you're going through the Paliagoda area, you can see these type of buildings. So you can find what are they. Then again, we can categorize type of emission as point sources and dispersed sources. Okay, point sources are vehicles and stacks. Dispersed sources are forest fires. Then again we can categorize ground level sources and elevated sources. So ground level sources are vehicles, elevated sources are stacks. Then again we can categorize type of emission as instantaneous discharges and continuous discharges. So the continuous discharges discharge the emission continuously. The vehicles, they are uh, intermittently discharge the air pollutants. Okay, some oil refineries, like some factories, can emit the air pollutants continuously. Once they shut down, their emission or release of air pollutant is stopped. Then let's learn about type of pollutants. We can categorize pollutants as primary pollutants and secondary pollutants. Let's see what are primary pollutants. Primary pollutants are directly emitted from the process. They are directly emitted from the process or the source. Directly emitted. Okay. As example, we can say ash from volcanic eruption or SOx's from the volcanic eruption. Then carbon dioxide from a vehicle exhaust. Carbon monoxide from the vehicle. Then sulfur dioxide released from a factory. So those are primary sources, primary pollutants. Then secondary pollutants. What are secondary pollutants? They are not directly emitted from the source. They are not directly emitted from the source. Secondary pollutants are not emitted directly to the atmosphere. Okay. The secondary pollutants are synthesized in the environment by chemical reaction involved in primary and emitted chemicals. So, example is a ground level ozone formation or photochemical smoke. Okay, those are not directly emitted from the source. See? So when primary sources emitted into the atmosphere, what happens? Those primary air pollutants react with each other or react with the compounds available in the atmosphere with the presence of sunlight or without the presence of other things. They make some other compound. So those compounds are called as secondary air pollutants. Okay. So example is a ground level ozone and a photochemical smoke. So photochemical smoke you may heard about. It is type of air pollution derived from vehicular emission from internal combustion engines and industrial fumes. So during A-level time, during a school period, you learn about this. So here you can see nitrogen dioxide is emitted from vehicles or factories. Then with the presence of ultraviolet sun rays, it is broken down to nitric oxide and oxygen radical. Then this oxygen radical react with O2 gas, oxygen gas available in the atmosphere and produce ozone. So these are the ground level ozone. So these are the ground level ozone. So why it is called as a air pollutant? So you may heard that ozone layer depletion in the upper atmosphere. So we have to avoid the ozone layer depletion. We have to avoid or we have to stop it because ozone gas is a useful gas in the upper atmosphere. Hmm? There's ozone layer, there are ozone molecules in the upper atmosphere. So ultraviolet B rays coming from the sun, ultraviolet rays, ultraviolet B rays coming from the sun is absorbed by the ozone gas in the upper atmosphere. But so it is a useful thing in the upper atmosphere. But when we talk about the ozone gas in the low atmosphere or in the troposphere, it is a pollutant. It is not useful because ozone gas is a greenhouse gas. Therefore, it can cause global warming. Another thing is ozone gas is a oxidizer. Oxidizer. So it can cause many problems to the human and the other physical thing, human living beings and to the physical thing. It can cause eye irritation, nose irritation, skin irritation because of its oxidizing power. You may heard that chlorine gas is an oxidizer. Huh? So it has bleaching power. So likewise, ozone also has bleaching power. Therefore it cause problems. So ground level ozone is a air pollutant. Ground level ozone is usually not available. It's not naturally available. But because of the man-made activities, nitric oxide will form from the nitrogen dioxide, and this oxygen radical leads to form the ozone molecule after combination of the oxygen gas in the atmosphere. And the other thing is this ozone gas help to form the photochemical smoke also. So likewise, then this oxygen radical will react with hydrocarbons and create aldehydes. And also ozone molecule react with hydrocarbons and produce aldehydes. Okay. Then again hydrocarbons react with oxygen, nitrogen dioxide and produce peroxyacetyl nitrate, which is responsible for the photochemical smoke. And this peroxyacetyl nitrate is a carcinogenic. It can cause cancers. Therefore, uh, ozone, ground level ozone is a unwanted or harmful thing. So now we are talking about type of pollution, primary pollutant and secondary pollutant. So let's say the second examples for secondary pollutants are ground level ozone, peroxyacetyl nitrate or smoke, photochemical smoke, and the nitric oxides are the secondary pollutants. Then again, we can categorize uh, pollutants as criteria pollutants and non-criteria pollutants. Okay, criteria pollutants are those pollutants that are common and found all over the atmosphere. Usually, the criteria pollutants can be found all over the atmosphere and they are used as indicators of air quality. They are used as indicators of air quality. Let's see what are the indicators. So here, this is the ambient air quality regulation of Sri Lanka. So here you can see those are the indicators, the suspended particulate matter or PM10 mean particulate matter which are less than 10 micron. Then PM 2.5 particulate matter which are less than 2.5 micrometers, nitrogen dioxide, sulfur dioxide, ozone and carbon monoxide. So those are the indicators of air quality. So if the carbon monoxide below 9 means it is a good air. If it is exceed 9 ppm, it can cause adverse health effects. Likewise, those are the indicators. So these are the criteria pollutants uh, in Sri Lanka. Okay. So, criteria air pollutant is a term used internationally to describe air pollutants that have been regulated and are used as indicators of the air quality. The regulation or standards are based on criteria that relate to health and environmental effects. So when you see this, you may be confused. What are these things? Let's see what are them here. This is average time. Average time. Okay, here this column shows the average time. And if we talk about ozone gas, average time is 1 hour. The maximum permissible level is in part per million or microgram per cubic meter. So when we talk about ppm, when we consider the ppm, the oxygen or the ozone gas maximum permissible level is 0.1 ppm for 1 hour average time. What does that mean? Or we can see nitrogen dioxide. Nitrogen dioxide for 8-hour average time, the maximum permissible level is 0.08 ppm or 150 microgram per cubic meter. So in this column, you can see the method of measurement. So no need to remember all these things for uh, your exam, but when you get these annexes, by looking at them, you should be able to understand what are the equipment or what are the instruments that we have to use to measure those things. So here for carbon monoxide, we can use infrared spectrometry. Likewise, here ultraviolet photometric method is used like that. No need to remember for the exam. So this is maximum permissible level for 8-hour period. That means, so we can see in a factory. You are in a factory where NO2 is emitted. So for then you have to measure the nitrogen dioxide concentration for 8-hour period. Okay, from 30 minutes to 30 minutes, or 1 hour to 1 hour, or from minute to minute. Then you can calculate the average uh, nitrogen dioxide concentration for 8-hour period. So for the 8-hour period, average the maximum permissible level should not exceed the 0.08. If it is exceeded 0.08 or NO2 concentration is greater than 0.08 mean, then the people and the other living beings can be affected. So it is the minimum level that the NO2 has to be kept. When we talk about carbon monoxide, the carbon monoxide level for 1 hour average time, it is 26. So in a room, some people are working in a factory, then the carbon monoxide level should be below 26 ppm or uh, 30,000 microgram per cubic meter for 1 hour average period. But when we think about 8-hour period, it should be below 9 ppm. Okay, so when you look at this, you can easily understand it. Then other type of air pollutant is non-criteria air pollutants. So those are not available in uh, to prepare the standards and regulation for countries. So non-criteria pollutants are the entire range of contaminants other than the criteria pollutant. So in our country here, you can see these are the criteria pollutants are included in the ambient air quality regulation: carbon monoxide, ozone, SO2, NO2, and PM10 and PM2.5. Okay. Other than this, there are many types of air pollutants. There may be hydrocarbons, aldehyde, ketones, benzenes, then SO3, H2S. So those are the non-criteria pollutants. Those are not available in the standards, and they are toxic and also hazardous. Non-criteria pollutants are also toxic and hazardous, and the concentration of most of them have not been studied. So here these are some examples. And some non-criteria pollutants are available in trace amount. Okay, so this is a homework for you. You have to find Sri Lanka Air Quality Index and how Sri Lanka Air Quality Index is calculated, and how does the SLAQI interpret it. Okay, then when you refer the handout to, you can easily find them. So in my lectures, I have in some of my lectures conducted in the classroom, I have explained those things about SOxes. You can easily find they are colorless gases and they are formed when fuel is burned. Like that, it is a criteria pollutant. Like that, then NOxes, they are thermal NOx and fuel NOx. Then this is the uh, this x-axis, the horizontal axis shows the time from midnight to 24-hour period of a day, from 12 midnight to end of the day, and the concentration of gases are available here. All of you know that photochemical smoke is formed with the combination due to the combination of ozone gas, nitrogen dioxide, and other hydrocarbons. So and all of you know that vehicles and factories discharge nitrogen dioxide and hydrocarbons from the early morning. Then with the presence of sunlight, those nitrogen dioxide converted into nitric oxide and radical oxygen atom. That oxygen atom is reacted with oxygen gas and produce ozone, and likewise ozone concentration increase at the during the daytime, and it is reduces, and the hydrocarbon is emitted. Likewise, this is the plot for the deviation of concentration with the time. Okay, then lead. So in our country, the lead is not a criteria pollutant. Lead is not a criteria pollutant, but in some countries, lead is categorized as a criteria pollutant because in the atmosphere, the lead can be found. Lead can be found. Especially, the lead is emitted to the atmosphere, especially from the gasoline-driven vehicle, gasoline or petrol-driven vehicle. But fortunately, in our country, the petrol or gasoline is not consisted with gasoline. Is not consisted with lead. Usually, lead is used to improve the octane number of the petrol. Okay, nowadays you have heard there are several types of petrol, 90 octane, 92 octane petrol, like that. Okay, so even for the diesel, there are super diesel and auto diesel. So you should know what is the difference between the auto diesel and the super diesel. That is, sulfur content is different in the super diesel. So, and the auto diesel, it has a auto diesel has a higher sulfur content than that of the super diesel. So and 90 petrol and 92 petrol, you should know the difference. So in other countries, in some countries, they use a method to improve the octane number of petrol using lead. But in our country, we are using platforming method where some platinum catalysts are used to improve the octane number. Okay, so because of that, fortunately, in our country, we do not want to include lead as a criteria pollutant because it is not uh, widely available in our atmosphere. So, for your information, I just at the refining process of crude oil in our oil refinery. So, no need to remember for this your exam, but for the polymer students, for the information of polymer students, I put this, no need to remember for your exam. So here you can see this is the crude distillation column, and this is here you can see the top gas is coming, and it is refined to it is processed to several unit operation, and LPG gas is taken. LP gas is taken. Then here you can see straight run naphtha. So naphtha is taken. Naphtha is taken and it is sent to naphtha unifiners. Naphtha unifiners. So usually the purpose of unifiners is to remove sulfur or something, remove sulfur and nitrogen. Then they are sent through platforming process to improve the octane number. Then gasoline is taken. Then it is processed further and petrol can be taken. So in our country we use platforming method, but in some countries the processors which use lead is used to improve the octane number. And also the lead is emitted from lead smelters, waste incinerators, utilities, lead acid battery manufacturers also release lead into the atmosphere. So when you talk about hydrocarbons, it is emitted from vehicles, and there are stationary sources, the petrochemical manufacturers, or in oil refining industry. Due to the incomplete incineration process, hydrocarbons are emitted. Then paint manufacturers and users also release hydrocarbons into the atmosphere. So this is the end of the lecture. So my dear my students, I will do the next lecture. I will record the next lecture and will be uploaded to the Moodle again. And I hope to conduct a live session to discuss about examination, um, discuss about the question which can be included in the exam. No, we can discuss our past papers in a live session.